Quick and dirty video time. I was just getting this old Breadmaker ready to go to the dump tomorrow. This thing has had a long and hard life, as you can no doubt tell. But as I was carrying this thing to the door, I thought, well, wait a minute, this should have a pretty decent sized motor in there, and I should probably take a look at that. I'm not interested in those control electronics, but the motor might be worthwhile. So I took off the bottom cover, and this is what I found. It's actually a belt drive. It's using a toothed belt to transfer as much torque from the motor to the mixer as possible. And here is the motor. And this is honestly twice as big as I thought it would be. And I want to have this. I removed the outer casing, and here is the motor. It does have a label on there. Top Summit, 230 volts. I'm not sure if the 97.1 is the power rating. Almost 100 watts, that would be. Some Chinese writing on there. Now, these things, most of them were cheaply tacked together in China. This was a really strange trend here in Germany back in the late 90s and early 2000s. Suddenly, everybody had to have a Breadmaker in their kitchen. And, well, of course, since these were all cheaply tacked together in China, or most of them were, it didn't take long until some of them caught on fire. And that was the end of that trend, because suddenly everybody was scared of using their Breadmaker. Except for my grandmother. This was one that she used many years ago. And, well, we do have there is a power supply in the back. A little transformer for the control panel. There is the motor run capacitor right there. So this is just a normal AC motor. There's probably, yeah, there is a relay that probably turns the motor on and off. Then over there we have a presumably very annoying beeper. The control panel also turns out to be a lot more interesting than I thought it would be, because instead of using application-specific circuits, they used this. This is an Intel P80C51 8-bit microcontroller. It's the very common 8051 type microcontroller, running at a frequency of 6 megahertz, it looks like. And then right here, we have two comparators, LM393. So this is actually quite a simple design. Actually not so simple because they are using a microcontroller, but it's using common components. Interesting. Now, a Breadmaker is not a very complex device. All the programs that this can do can be broken down into two basic functions, and that is mix the dough for a certain amount of time and heat the dough to a certain temperature. Now, the first function, that's fairly easy. The microcontroller has a timer built in, and that can be programmed to run the motor for a certain amount of time. Now, the second function is a bit more complicated, but then again, it's actually surprisingly simple. Here is the baking chamber with a heating element inside. The dough was inside of that, which sat in there. Yes, this is all incredibly nasty. Now, there is the connections to the heating element, and then there is the temperature cutout, which would prevent the heating element from overheating, and clearly on some of the Breadmakers that didn't work because, well, if this doesn't work, then the thing's going to catch on fire. It's going to overheat. Now, so what would happen is initially the microcontroller would run the heating element at full power, and only the temperature cutout would make sure that the heating element did not overheat. Now, the heat inside the baking chamber rises up, obviously, and eventually the upper one of these two temperature sensors is going to reach a certain set target temperature, at which point the control module is going to make sure it's going to start pulsing the heating element to make sure that the temperature inside the baking chamber does not go above that target temperature. Now, the dough inside absorbs the heat until it's done. Now, once it's done, the heat, well, it can't really rise up because it's restricted by the cover, and it can't go into the dough because the dough is done. So it's going to start building up, and eventually this lower temperature sensor is going to reach a temperature that's very close to the target temperature of the upper sensor. And when it reaches that temperature, the lower sensor, that is when the microcontroller knows that the dough is done baking. And this makes sense because the two temperature sensors were connected right there. You can see there are two potentiometers to calibrate those temperature sensors. And then that is all right next to the comparators. So I guess that's how the heating function worked. So here are the useful parts out of the Breadmaker. Of course, most importantly, the big AC motor. There are some useful parts on this circuit board, so I'm going to part that out. And then the microcontroller. Now, I'm not sure how you would program this. I certainly don't have a programmer for this right now, but I might be able to reuse that for something in the future. So that's going to stay as well. And the comparators. Thank you for watching.